Everyone, welcome to 369 Chemistry, and today in this video we are going to solve the question based on your novel condensation. So for graduation student, the BSc student, it is very important. Okay, graduation student, for postgraduate also it is also important. So the last time we did what is novel condensation, its mechanism, we have done in the last video. Please go through that if you have not seen. And in this video we will solve the numericals. Okay, so before going to the numericals, the one most important question which comes in examination is explain why in novel condensation the use of excessive active methylene compound is not recommended. So in because we know that this is the condensation of your aldehydes or ketones with active methylene compound, so excess of active methylene compound is not recommended. Why? So here the answer is, see, first let me draw this and then I'll write the answer. So see here, this is aldehyde, right? And it is reacted with your, here you have active methylene compound C double OO C2H5, and here also COO C2H5. So this is an active methylene compound. Okay, this one in the presence of a base, that is the pyridine out here. So in this case, in pyridine, what we get is this one, H3CC, CH double bond C, then you have C double bond OO C2H5, that is alpha beta unsaturated compounds is formed, right? This is the thing which we get as product. But what happens if we use this one as axis? So let's see the mechanism. See here, this is the product which we get through this reaction, right? So now we are going to use axis of your this one NaOH. So what happens if this is an axis? Okay, that means then another active methylene compound will be forming. If it is axis, the reaction will continue, right? It will react more. So now this one, what it does, this active methylene compound, it will go and attack this carbon double bond. Why? Since here it has more electron, here it is a double bond, that means pi electron is there, pi cloud is there, so electron deficient, and this one will come out here and this oxygen will pull the electron towards itself. Okay, so what we are getting is, see, this is the bus following from the previous step. So here it will be H. If I put this H up here it is C, this is the carbon one, here it is H. Okay, and here it is normal C, this carbon COO C2H5. all right. Okay, and here what is it is adding, this whole one is going and attaching outside out in this carbon, right? So it is going for addition reaction right now. So here this is getting attached, so here again it will be COO C2H5 COO C2H5 of this molecule. Okay, active methylene compound will be in axis. If you if you are using this one in axis, so this addition reaction is now going to form here. Now see here, this is the carbon, here it will be again carbon carbon, another carbon double bond O minus, and then here O C2H5. so this will be now the this will be your final intermediate structure. Now there is a base, right? There's a base, this is the base formed after this reaction here in this step. So this one is going to take up the hydrogen of the base, generating the base back into the reaction, and then what you're going to get, you're going to get H, here CH, then COO C2H5 whole twice, okay, of this one, and here it is C. Here if this one takes up your hydrogen, is it not? So what will happen? So this is going to now form this way. Here it is COO C2H5. okay, is double bond O, here it is OH, then OC2H5, right? So what is happening? This one is migrating, this hydrogen is going to migrate out here. Okay, Here see, just because this one is a unstable product, here this is unstable, this is the unstable product. So for stability, what is happening, this hydrogen is going and attaching itself out here, okay, and here it is again forming back your C double bond O OC2H5. So this is the molecule which is forming here for this is the addition reaction, okay. Here again CH COO C2H5 whole twice. Here also this is H, this is this carbon, and here see there is 2, so it will be CH because this H has come out here, CH and COO C2H5. So if axis of this methylene compound is used, see this is the one which is in axis we have used, and we are getting some addition. So we are getting this addition as product. So this product is called your Michael addition product. Okay, so Michael's reaction is also another question. So this is Michael's addition product. So what we can say, if we use active of excess of your active methyl compounds, then it will undergo Michael addition reaction and it will be initially formed. Initially unsaturated compounds will be formed, and then it with the use of excess methylene compounds we are going to get Michael's product as the reaction product. Okay. So if this is A, now if this Michael's product, if this is undergoing hydrolysis, then it will form these two groups. It will form your C double bond O H. It will convert this ester into your acid groups. Okay, so what will it be? It will be like this. See, here this H, here it will be COOH. Okay, COOH. Okay, again see here it is H. This is this carbon, then this carbon, and okay, and this carbon is attached to another one hydrogen. This is the hydrogen that we have I have written this side, and this carbon I have put above out here. Okay, just for our understanding. Okay, so here it will be COOH, here also it will be COOH. So all these ester groups now converted into your acid group after hydrolysis. So if this one, it will, if you heat it, then there will be 2 molecules of carbon dioxide, CO2 is right, the 2 molecule of carbon dioxide will go out, and the final product will be this. Okay, here it will be CH2COOH, one acid group will be there, here also CH2COOH. So this will be your final product. So now let us solve some questions. So this is a question, Aldol condensation. So this is a group which is given active methylene group. Here there is a pyridine. Now you have to, so now what you are going to do, now you let us do the mechanism and solve, and let's see what will be the product. Okay, so first this base, okay, this base is going to take up the hydrogen. Okay, there is cyanide group, and here it is COO C2H5 group. Okay, so it is going to take up hydrogen, and now what will happen, it will form like this, right, and there is a formation of, here see, the base becomes positive. So this is formed. Now what will happen, now this one is the active methylene group formed, so it is going to react with this ketone which is given to us. Even if there is any groups given out here, these two, there is no problem, there will be no difference in the product, there will be some addition only, and there is no you don't need to be scared whichever group is there in these two sides. Okay, there is nothing to be getting scared, just follow the mechanism and you are going to get the answer. It will give this CH3 C, CH3, here it is C, okay, here it is O minus, and here it is H, right, then it is Cn, and there is COO C2H5. This way you can write, you can also change it. Okay, now you can also write this one as like this. See, O minus you can write here in this side, H, here it is Cn, and here it is COO C2H5. Now as there is this base, right, so this one is going to, this OH is going to take the H plus, okay, regenerating your base which you have used, and you are going to get this product. See, OH, here it is C, here it is H, this is cyanide, and you have COO, C2H5. Then small molecule, water molecule will go out, minus H2O gives you your alpha beta unsaturated compounds. Okay, CN, COO, C2H5. So this is the first product you're going to go. And if they say hydrolysis, then you have to do hydrolysis. If not, then leave it. So if it is said like this, if it is given in question, hydrolysis will be there, then there will be hydrolysis. Okay, so what will you do if hydrolysis is there, if you're doing now? Okay, detail hydrolysis with showing the mechanism how this OH minus ion goes and attacks this carbon and everything. I have done in the other video. That is the first video where I have discussed about novel Aldol condensation. Here we are going to just directly write these two groups will be converting into your acid group. So how to convert that I have given in details. So in this solving questions we are not doing this. Just go through those videos for your reference. Now see, here it is acid, right? Both the groups forms an acid. So see here, COO is there, so there will be, if you heat it, one carbon dioxide molecule is going to go out and you're going to get this. If there is some other groups, remember that always one molecule of carbon dioxide goes out from one carbon attached to it. Okay, one carbon. But if suppose there is somewhere out here also there is something more saturation is there, more number of ester groups is there, that times two molecules of carbon dioxide goes out, or else it is always one molecule of carbon dioxide goes out, and alpha beta unsaturated acid is only formed as your final product. So after hydrolysis, this B will be your final product, and this is your A, product A, which is before hydrolysis, right? Okay, so this is another question, number 3. Okay, these are all practice question, important for your examination, so do practice it so that you don't face any troubles. Okay, so again, see, the first step is the generation of your active methylene compounds from the given reagent. Okay, so just follow the mechanism and it will be thorough for you. Okay, see here, this one is going to, and something there is a molecule where from you can take up hydrogen, and you know there is a abstraction. If base is given to you, always there will be formation of carbon ion intermediate, and with carbon ion intermediate with the removal of your hydrogen ion. So remember that here, formation of active methylene compounds, carbon ion is formed as the reaction intermediate, then that carbon ion, it is going to now react with the reagent given to you. See, this is an acid, here it is carbon, this is an aldehyde also. Okay, so don't be scared by looking at the molecule, just follow the steps of the mechanism and you are going to you can solve anything. Okay, so this is going to now go attack out here. Okay, and what it is going to form, it is going to form like this. See, HOOC, C O minus, here it is H, here it will be C H, COO, C2H5, COO, C2H5. Alright, and now the base which was there, it has excess of hydrogen. Now it is going to, O minus is going to take up the hydrogen, and then you are going to get back your base. Alright, which you used. Now the product is OH, here it is H, here it is C, here it is H, COO, C2H5, COO, C2H5. Removal of water molecule, very easy, minus H2O. Okay, so it is HOOC, C, H, double bond, C, COO, C2H5, C, OO, C2H5. Now again in question, hydrolysis is given, H2O. Okay, hydrolysis is given to you. So what happens if it is done? Hydrolysis is done, that time what will happen? This is the one, right? Here it will be COOH, here it will be COOH. Okay, now, so what I told you, one molecule of carbon dioxide will go out and then you are going to get this as your product. Double bond C, H, C, OOH. Okay, here see, if one carbon dioxide molecule goes out, this hydrogen is going to go and add out here, right? So this is the product final before hydrolysis. A is the product. B. So there is another question we will do. This is the last question on Noble-Hazel's reaction, and this is like how to prepare fullerenes. Okay, so fullerenes are prepared by this your Noble-Hazel condensation. Let's how see this. There will be an aldehyde, acetaldehyde. It is reacted with this heterocyclic compound. And then in the presence of Na2C2H5. So this is the base used out here. Okay, CH3 CH double bond. This is formed as your product. Okay, so this is your fullerenes. Okay, how to prepare this? Let's see here, this one, for making an active methylene compound, what we need hydrogen, right? We need hydrogen to go on. So here also see, this is a very electron deficient carbon also, because carbon double bond is there, okay. So here there is hydrogen also. So let's see, here you have an A plus O C2H5O minus. So this is the base used, and this, see here, this is hydrogen, this is hydrogen. Okay, so what you are going to get, you are going to get this carbon ion right now. This is highly unstable carbon ion because of its aromatic character. Okay, highly unstable. Why? Due to aromatic character. So now this is going to react. Okay, electron deficiency wherever is there, it will go and try to attack there. Follow from the previous structures. Sorry. Okay, this is formed. So again, in the base is there, in the intermediate C2H5O, here it is going to regenerate the base minus C2H5O minus, and it is going to form like this. C CH3 C OH H C H. Okay, so now what will happen? Small molecule of water will go out, and you have this double bond. See this as your product. Okay, so we have got this one as our product. This is called your fullerenes. So this is done with your Noble-Hazel condensation, all the important questions and all. So next we are going to do, we'll go for another name reactions in the next video. So if you are interested and if you want to know some other videos on other topic, please do write in the comment. Thank you so much.